Bob's a principal engineer at MITRE, and he's been there for, I don't know if I can count that many years, since 1981. And for the past 16 years, he's focused on the interplay of risk management, cybersecurity, quality assessment, and the use of software-based technology. So Bob's really been a pioneer in defining the risks around using software, and I can tell you that in my work I use CWE. I think it's a great thing. So welcome, Bob.
Thank you. And hopefully one of these days we'll be done with it and people won't discover new ways of making applications insecure. So what I hope to do is give you an introduction to what CWE, what the common weakness enumeration is, and how you can use it for testing, how you can use it for application development and trade-offs and many, many other different use cases. But basically, think of it as a couple things. One is we're looking to improve the quality of software from a security point of view, and we are talking about architecture, design, or implementation. One of the other aspects of this is we want a measurable set of things you can go look for or learn about to avoid doing. We want to enable discussion about these issues. So, for instance, in the architectural level, I very much doubt we're going to have tools going out and finding and identifying security issues in architecture, but we as humans may discuss and debate architecture and security issues, and so let's have agreed on definitions of those concepts and those issues so that we don't just keep talking past each other. And also, in that we have a lot of code and we're going to have a lot of more code, we want to support automation in those assessments, in those understandings of risks. So we want to understand how to identify good tools, effective tools, and appropriate tools. So CWE is trying to answer those, all three of those, and different people will say it's strong in one or the other and getting stronger, but that's our mission statement, as it were. When you go look at application security, there's a lot of different aspects, a lot of different groups involved. There's, if you look at it from on high, there's people making mandates about security. There's people trying to do research about application security. There's the people who want to look at code and do white box types of investigations. There's the pen testing, black box testing types of issues. There's people who want to give you advice about how to avoid things, how to find things, how to mitigate things. There's people who want to help you prioritize through all of the different guidance and ideas. And there's people who are trying to acquire secure applications. And there's project managers who would like, if they can understand how to do it, to actually have secure applications from the projects they're putting together. The trouble is, how do these different groups actually talk about the same concepts from their different perspectives and know they're not getting confused? So one way of looking at CWE is that Rosetta Stone that's trying to bring these different groups together so that they know they're talking about the same issue when in fact they're trying to. So for instance, CWE 79. Okay, Connor, which 79? Yeah. Oh, I could have asked Steve Christie too.
I guessed SQL injection.
Well, it's one of the tops, right? So the idea is a mandate about cross-site scripting. Make sure all our applications are tested for that. So the idea is that, well, how critical is that in the OWASP top 10 list? Oh, that's pretty high up there. Well, we ought to tell the people that are acquiring applications to go look for that. Make sure that, we talk to the service suppliers and vendors about that. In our applications, what are we doing to look for those kinds of issues? In the advice sites, what's out there? What can we pull together and bring to bear? In the actual project manager, do you have time for testing? Have you looked at that issue? So on. So how did we get going on this? Well, there's a lot of work that's gone on in faults and flaws and ways applications can be going wrong. If you look on the left of this slide, basically you have things from the 60s and 70s and different types of fault analysis and different kinds of looking at how code and applications can go wrong. If you go on the far right, you'll see an effort called Plover, which was the preliminary list of vulnerability examples for researchers, which was based on reported CVEs, so publicly known vulnerabilities. What was the root cause of them? Well, we pulled 1,500 of them, analyzed them, and came up with about 300 things that actually were the root cause of those. So then there's other efforts, Microsoft's efforts to structure the different classes of issues that they were worrying about through Mike Howard's books. CLASP had a taxonomy, WASC had their work, OWASP. So there's a lot of work out there trying to get a handle on this problem. And it's a lot of good work. And so what we did is we actually merged it together, plus MITRE, as a not-for-profit running federally funded research and development centers, went out and has been signing non-disclosure agreements with a lot of the organizations that either have tools or knowledge or service or just a lot of caring about these issues, to get their understanding of these issues and put it all together with that open source, as it were, research that had been done before. So when you look at CWE, it's all these things together. We've got a slide transition problem. So we started out with Plover, and then in 2006 we had another draft, 2007, now we're up at 2008. These are all called drafts because in a precision, really fully vetted thing that you can rely upon and every piece is as strong as every other, we're not there yet. But we're getting close. We hope to get to draft 1 this, or release 1.0 this year, in fact this summer. But basically we've been putting together this information, trying to deconflict the different sources, get common terminology, some people had a focus on testing, some people had a focus on risk issues, so we're trying to merge those together, fill in things. And you can have, draft 8 went out at the end of January. Draft 9, hopefully, will be at the end of March, maybe the beginning of April. And we'll keep moving. That keeps Chris and one of his compatriots, Chris Eng, very on the top of their form, right? Doing the diff reports. But basically, the last version added 22 more CWEs, so we're always adding new content. But we also, this time we added a bunch of design weaknesses. So, it's not just implementation issues. We're trying to get the different areas covered. One of the ways I sometimes talk about what we've been doing is, well, how many things have we, identified? That's a good metric, right? And so if you look at the different drafts, we got up to draft 3, and that's when we started pulling in content from a lot of other people through the NDAs. We had been brought in CLASP and 7 Pernicious Kingdoms and all that information from kind of the open source before that. And we went through a couple different drafts, and at one point we said, okay, we've got enough information here. I think we can envision what we really want to have in CWE. Because, basically we were pulling in all this content from different sources, and, one of them had 15 different attributes that they were tracking, another one had 18, one had 3. We were trying to figure out, okay, what is the good minimum types of issues to cover, and then do those well. So after draft 6, we basically did what we're calling the CWE scrub, and we're still scrubbing. So another way of looking at CWE is it's basically completeness of full definitions, that all the different aspects of each issue is fully defined, fully worked out. And so once we decided on our measuring point, it got pretty sick. all of a sudden we had a criteria for success, and a lot of them weren't up to that criteria. So what we've been working, draft 7 and 8, is trying to fill in those gaps in restructuring, full definitions, and a couple other things. Draft 9 and hopefully version 1 is where we're up now to all the nodes have, their minimums met. So what are those minimums? Well, you can see MITRE does a lot of things very openly. So there's our own analysis of what was wrong with draft 6, and what our Get Well plan is out on our website, all the different issues we were trying to work out. So I'm not going to bore you with reading through those for you here. But the scrub basically was taking and putting out key principles that we wanted CWE to have, and then going through and like language-specific issues, technology-specific issues. We wanted to have these covered in each node so that people with different points of view could kind of carve through it, taking a swath through it for things that deal with C or things that deal with Intel platforms, and not have to wade through all 600-700 nodes. And then contexts, like things have to do with files, technology. So different ways of going through this. So many of the earlier works were all depicted as taxonomical. They had some structure to them, and when the next question came along, that structure couldn't answer those questions. So what we're trying to do is have all the low-level concepts, all the low-level types of issues that are problems identified, get good agreement, and then you can have different structures built on top of that depending on which cut through that knowledge, that dictionary, that encyclopedia you want. And so that's one of the big differences in what we're doing. So here's kind of the outline of topics that each of the nodes is supposed to cover. So, an ID, a name, a description, actually a short description, and then an extended description. So like a 2-sentence, what is this issue about? And then the longer ones. Different terms, demonstrative examples, and so forth. So, and then other things about mitigations and types of issues, how you can be attacked by these. So a lot of different aspects. We're also taking in as many different points of view or stakeholder points of view as we can. So these are all listed out on our website, as well as what we think that stakeholder's interest in weaknesses is. What are they going to use it for? Why are they care? What aspects of it are more important to them, and so forth. Then we've gone into all those fields we defined. Well, what are the completeness goals? Why are we trying to, get all of this field for every issue and only most for some other issue? What is driving that? And we bounce that against the different stakeholders about why they care. So each of those columns is one of the different stakeholder groups and their priority versus the different fields and their fullness. So we're trying to be as thorough as we can. The other part is usage. How are you going to make use of CWE? So the point of all these is, if you go through and you look at these and you say, well, I think I really want CWE, but I'm not identified by this stakeholder, or these usages aren't quite making sense, please let us know. Let's talk about it, because we're trying to make sure it is fulfilling the usages of people who actually want to use it versus us who are creating it. We have a lot of discussions, but we're not omniscient. So we've put together views. This is that slice through CWE. So you don't have to look at all the nodes. You may only look at 30 of them, because that's what's germane to your type of issues. So if you're only worried about web applications in JavaScript and Perl, you ought to be able to just find those kinds of issues and not have to worry about, you know, some other type of language or design constructs. So we've put together a bunch of views, but I'm not sure that they're all the views. One of the big moves from draft 8 to draft 9 is to clean up our schema so we can support views as many as we want very efficiently. So the ones we have up there, C, Java, C#, sorry, C++, not C# yet. PHP, also OWASP Top 10 has CWEs in the last version, the 2007, so you can go look at all of them. You don't have to go find them. Those are just simple exemplars of the concept of a view. They're not elegantly done, but the idea, a lot of people saw those tree charts I showed earlier and started thinking that was CWE. And no, that's one way of looking at it if you happen to want to look at everything, but most people won't. So these views are how we envision most people actually making use of the material. So think of CWE as, yes, there are some people who want to look at all the views. There's other people, whoops, sorry. Well, there was a couple different views, but underneath it all, there's C specific. But underneath it all, any particular view has some organizational nodes, some grouping type of, you know, parent, because it's of a higher abstraction of that weakness, and then some lower weaknesses that are of a same type. So if you looked at all of CWE, you're going to see a lot of different kinds of nodes. But the idea is you may only want one subset. So right now, my clicker is off by one. So this is what we have out there now, is 55 categories, 77 groups, 265 types, and 256 variants. So types, variants, all these terms are defined on the website, but just think of them as abstractions and ways of organizing all this material so that we can have rules about, you know, variants have to have this kind of information in them, types have to have some other stuff, and so forth. So the node types, we started out with just categories, so, you know, a parent node and a child, and then variants would be technological differences, whereas now we also have groupings. So those views, those slices, those are groupings. So those are different ways of organizing nodes. So an example would be issues that affect files is a grouping, whereas insufficient input validation is a parent to path traversal as well as cross-site scripting. So those are just some examples of different uses of this. So this is our health report. We have 187 nodes with no parent and no child issues. So those are the good ones. Everything else is either missing a parent, missing a child, or has some other issue that we're trying to track down and work through. So I'm just showing you we're over-metriced, or at least over-measured. Another way of looking at it is we've been tracking these things over different versions. You know, obviously we want more and more green, and we're not getting there yet. But by draft 1.0, that's our criteria. So it's not a calendar date, it's a quality point, which some of my sponsors seem to have trouble understanding that. What do you mean you're not going to be done by this certain date? So we have this document up there. It's now available also as a PDF. It defines each field and what the field is supposed to have. So this is what we're using to make those red, green, blue evaluations. It's also, if any of you want to contribute content, here's your cookbook for offering up objects. And we have, under NDA, a couple organizations supplying new nodes and corrections. So draft 6 to 7 did a lot of cleanup. It's obvious just from the screen. You can see everything that got changed, right? Well, maybe not. Little details, like you can say something holds for all code. It's not, you didn't have to list every single language you wanted. Now we're also finding that there needs to be, quote, all code with an exception list, because some things aren't quite for all code. But the idea is we've been going through with these kinds of cleanups, going through content. Remember, a lot of this content was donated from lots of different sources, had different business drivers behind them. So adding in children and parents and relationships. Draft 7 to 8 had even more changes. One of the things is we now have summaries. So sometimes you would come into a definition and a paragraph, 2 paragraphs, a page later, there was your definition. A little too much for somebody who's trying to browse through and find things. So now we have a very succinct 2 or 3 line description that we're trying to hold to that criteria. Of course, once we get lower down, it gets a little dicey to actually be succinct when you get there. We've also added references section to CVEs. It's always been there, but it was a little hard to find it. So these are real-world examples of that type of issue. So, if you're trying to explain to your boss why they should care about this kind of coding mistake, here are public vulnerabilities in those products, We also, in draft 8, pulled apart weaknesses from attacks. So there's another effort called the Common Attack Pattern Enumeration that talks about specifically attack patterns. And most, if not all, of CWE now has weaknesses, not attacks. Although some of our names still have to change. But they describe the weakness that an attack goes against, as opposed to quite often today, we end up describing the attack, not the weakness. That's been a problem. So those KPEC IDs are in there. Another thing is we have a bunch of people now trying to follow what we're doing. So we've added diff reports, changes in the schema, as well as changes in the content. So we're trying to make sure that we understand what we changed and why we changed it, and make it so other people can follow it. And which ones are minor changes, we typo, spelling mistake, versus big, we added 3 languages that this weakness applies to, type of thing. And part of that is we now have 23 products and services that have declared their support for CWE, and from 13 different organizations. And this program started at RSA last year, and now about half of them are actually shipping product with CWE tags or teaching courseware, because a couple of them are actual teaching, training, academic institutions. This is our community. These are the group of people that we've worked with, talked with. Some are big contributors, and some are just people we've bounced notes off of, and so forth. One of the side effects of CWE is that we've also had to get into understanding weaknesses and how they interact with attacks and operate. So we basically have a document which we call Introduction to Vulnerability Theory, which tries to kind of lay out the mechanics or mechanical science of these vulnerabilities. And that's helped us in describing things and explaining things. And one of the outcomes of that is, terminology. So when we're rewriting all of these different descriptions, which came from different sources, we needed some benchmark to normalize it. So this has helped us with that. And, triggering issues, facilitation, interaction points, crossover points. I'm not going to go into detail. Steve can go into detail at the break if you want. But one example of it is in code samples. How many of you have seen code samples and been reading the book that had the code sample, and you're trying to follow what they're explaining and you really can't see it? You just can't figure out where they're talking about what. Well, one of the ideas with these concepts is, for this code sample, cross-site scripting, well, there's an interaction point at line 3 and 6. For traversals, the interaction point is only line 3. For overflow, the interaction point is line 3 also. So now, with these succinct concepts, you can look at the code and see where those different issues are really at. And we found it's very useful in teaching people and getting discussion on what's going on. Another issue that we've been working on is basically, we're calling them chains. It's basically that several types of weaknesses seem to follow each other. That, for instance, having an integer overflow can lead to a heap overflow. So they're two different weaknesses, and if you see one, you may or may not see the other, but you may want to look. But if you don't know that that relationship could be there, and it's actually when they're together that they're more dangerous. So this idea of chains, just to let people know you're looking for one, look for the other, or at least understand that their possibility is there. Both of them have CWEs. The idea is that if there are certain chains, and they could go on for more elements than this, but if there's an important sequence that really happens a lot, that also would get a CWE, that chain itself. Not all chains are going to get CWEs, but the idea is that this may be also something that code analysis tools find. They see one of them and implicitly assume the others happened, and yet they didn't really see it or such. I mean, the idea is this is where some of the obscurity and differences in tools and different methods could be coming from. Another example is in composites. So relative path traversal, it's a very well-regarded concept, but it turns out it's actually built on a couple underlying weaknesses, and if one of those isn't there, then that overall concept, that composite, won't be there. So again, if a tool's finding one of the underlying issues and projecting that, oh, I found the big issue, well, maybe they didn't. But this also then gets into, well, maybe I can prevent that larger issue that by intervening on one of the legs that are keeping that stool up. So, and as you notice here, design level issue. Well, that's going to be hard to change, whereas maybe that one of them is actually a configuration issue, and another one may be a code implementation issue. So if you understand what those different parameters are, and this is not the one to generalize on, but the idea is to recognize these, and Draft 8 started showing some of these also. And Symlink following is another example of some design. Here's is a permissions issue, so it's a configuration issue. So the easiest way to change that, to remediate that would be to change your configurations so that the permissions are correct. Whereas another way would be to go back and change code or change design. So the idea is to let you understand the nature of the beast you're actually working at, and this work has started to uncover those. So here's some composites and some chains that are up on our website. We're still playing around with good ways of presenting the idea of composites and chains, but this is something that's come out of this. So I mentioned that the OWASP Top 10 uses CWEs. So does the NIST work at Summate for their functional specs. OMG in some of their model-driven security software assurance work. CWE is an element of that also. And also the SANS Institute, their secure coding exams. Underlying that kind of as the landscape for those exams, CWE is part of making sure it's complete and that it covers the newer issues and the different variations. This is, I don't know if any of you got SANS poster this year, but CWE was the theme of their secure coding poster, and it shows the blue is kind of general CWEs. The red is from the top the CWEs behind the top 2006 CVEs, and the ones with either yellow or yellow bordered are the OWASP Top 10 CWEs. So it's showing you which ones are actually prioritized by OWASP or behind a lot of the more popular types of publicly known vulnerabilities. At DHS and DoD, they have the software assurance working groups and forums. CWE is one part of that venue also. So if you're interested in that area, there's some interesting work going on there. And also the National Vulnerability Database. They used to have a home-brewed set of labels that they would tag each publicly known vulnerability with. They've dropped those, and now they're using a subset of CWE. Now, CWEs can go way down into real detail. When you're reading an advisory, you don't have that kind of detail. So we basically work with them to identify about 18 fairly high-level concepts that it's reasonable to expect when you read an advisory, you would know enough to pick one of those 18. So it's starting to give you a little bit of the background, what kind of issue is behind this publicly known vulnerability in a structured way. And it'll bring you right into the CWE definition of those, right from the National Vulnerability Database. I can speak to this for an hour, but I'm not going to. The top of this is all the different groups and different sources that we're bringing information in to CWE, but you'll notice a lot of those are two-headed arrows. And that's basically, we're trying to make sure that what we're doing is good enough that the people want to bring it back and actually embrace it within what they're doing. The bottom is a lot of efforts that are leveraging CWE and building on top of it, as opposed to sources we were involved with that are, pulling it back. Another way of looking at software assurance, and you'll have these charts, there's a lot of different topic areas up here. CVE is the bottom circle there, publicly known vulnerabilities. CWE up here, well, there's attacks, there's different tool efforts. So in the software assurance landscape, this is kind of a knowledge map, and it's a way of trying to, get the different concepts in your head and who's working on what and how it fits together. So I encourage you to look at that too. And I have 2 more charts. This is an effort we're doing at MITRE that's focusing on a lot of different domains in information security. On the far left is software assurance and building new systems, bringing them into your enterprise. Along the top is your typical enterprise security, network security. You know, what assets do I have? Are they vulnerable? How are they configured? What's happening, intrusions, and so on. Well, CWE actually plays a role in incoming threats against code that you've developed. So the idea isn't that there's a publicly known name for that problem that you wrote in your own code, but the idea is you could actually have, oh, there's somebody out trying to take advantage of cross-site scripting or this variant of it. And so you could bring that in and help your enterprise in how they manage if they understood what CWEs were and how to prevent them and work around them. So if you want more information about that last part, you can go to makingsecurity.mitre.org. And the last slide I have is if you want to get involved, we have a researcher list which has a public archive. Hasn't had a lot of discussion. There's been little spates of it, but that'll be changing. We've been doing enough of our self-searching and talking to people in private that we need to get it out and bounce ideas, and that's part of what we're doing here too, is we think we're on track. We've talked with a lot of people that seem to be engaged and have given us feedback, and definitely we don't know all the answers, and we're interested in as many questions as we can get. And with that kind of an opening, I'll ask anybody who has questions, or I'll be here for the rest of the week too. So yes.
You mentioned the role of the CWE in facilitating communications between different communities of humans.
Mm-hmm.
Have you also anticipated the use of CWE as a machine-readable model of these different vulnerabilities? So, for example, that these ideas of vulnerability chains and composite vulnerability, you can imagine a static analysis tool, using that model to say, okay, I found these 4 weaknesses, therefore I can identify the
Right.
composite relative tactical.
Okay, well, we're definitely one of the outline that showed all the fields in a weakness. 2 of the newer fields were black box definition and white box definition. I think we have 13 white box definitions right now and no black box definitions. But the idea is to get more to a formal tool recognizable part of that. We're not anywhere near that, but we see that there could be useful work done in that area, so we at least have a handle for it. Basically, there's also with the tie to the attack patterns, there's, you can start looking at the attack patterns, attack trees, and you're looking at your architecture and your threat surface, and there's lots of different coupling. We're trying to make sure we have some good bricks before we start building a castle. So
for chains and composites, the schema does hold a number of different relationships. The main one being parent-child that builds those massive trees that you see. But we have ways of representing chains and composites that have their own sort of special relationships. And Connor, you probably remember the names of them particularly, but we have like can contribute to or is a component of. So by navigating through the schema, through those relationships, you can grab that stuff. Now, that's the state where it is right now, because as Bob said, we're still kind of new at formalizing the concepts of chains and composites. But we anticipate in future drafts, and certainly by 1.0, whatever 1.0 is, that there will be an easier way of being able to get at those.
right, and we've also gotten feedback that it'd be nice if we offered up some style sheets to, take, because the actual it's in XML, it's available in XML, but it's a very complex structure. And so just reading it as raw XML is kind of hard. So some of the style sheets we're using to present it on the web and other ideas, making those available for people to use against it also. So we're open to those kinds of questions. Some of them are the V8 moment, like, of course, that's easy. But we hadn't thought about it. So, well, I thank you, and hope you have a good rest of the workshop.
Thanks, Bob. You'll see that there's some evaluation.